Hello, my name is Jerry, and today we will be going over cargo, libraries, and the RAND crate. Our goals for today are to learn some cargo commands, learn what crates are, as well as use the RAND crate. For optional reading, check out the Rust book chapter 14, more about crates and crates.io. More about cargo and crates.io. So what is cargo? You've already used cargo before, such as cargo run and cargo build. But Cargo is a lot more than that. Cargo is a build system and package manager. It lets you compile your code, but it also allows you to download libraries, run tests, as well as manage dependencies. Alright, let's create a guessing game to explain Cargo. So in the terminal, I've already made a new project by running Cargo new guessing game. So now let's just open up VS Code. As you can see, there's um, there's a source folder which contains the entry point, your main.rs. There is also a target folder which contains build internals, as well as a cargo.toml, which we'll talk about later. So here are some basic cargo commands that you should know. Cargo check is the fastest compilation command. It will only check the code for errors without generating a binary. Cargo build will build an unoptimized binary. So that means the build time will be faster, but the runtime will be slower when you run the binary. And cargo build with the release flag will take the longest to run, but it builds an optimized production binary. So this will be the fastest when you run the executable. There is also cargo run, which compiles and runs binaries, as well as cargo test, which compiles and runs tests. Now let's look at the cargo.toml file. So there are two parts. The first part is the package. It contains metadata such as the name of your project, the version, as well as the edition of Rust you will be using. Then there's a dependencies section. Here, this contains any crates and dependencies you may want to import. For example, the RAND crate. So what are crates? Crates are the smallest units of compilation in Rust. It's the smallest amount of code that the Rust compiler considers at a time. A crate can contain modules and multiple files. And there are two types of crates, binary crates and library crates. So, the binary crate has a main file. That means that it produces an executable and you can run it. On the other hand, library crates do not have a main file. Instead, they're meant to be imported and reused. A big use of library crates are external crates. There are many user-built crates that provide functionality the standard library doesn't have, for example, random number generation. To find these crates, first go to crates.io, then look for the crate that you want. For us, this is the RAND crate. And then over here on the install, you can find two install commands. You can either directly add it to cargo.toml or you can copy the install command. So let's talk about the RAND crate. It provides functionality to generate pseudo-random numbers. A common way to import the RAND crate is to use the RAND prelude, which imports the most commonly used traits and functions. Some common functions of RAND include the random generic function. So it will generate a random value of type t, which is whatever type you give it to the generic. Here, since t is an unsigned 8-bit integer, it will generate a random integer from 0 to 255. Another function is the random underscore range function, which will generate a random value within the range. So here it will generate a random value between 1 to 5 inclusive. For more information, you can also go to the docs.rs to look at the whole documentation. Now, the RAND crate also exports some traits. For example, it extends the vector structure to include the shuffle and choose method, but these methods require a random number generator. So to create a random number generator, call the RNG function. Note that you must import the prelude for these vector methods to work. So now let's take a look at it in action. So here, I import the random prelude, which will give me the methods shuffle and choose. And here is the random function that I was talking about, as well as random range. So now, when I cargo run, as you can see, 180 is a random number from 0 to 255. 2, it generated a random number between the range 1 to 5 inclusive. And when you shuffle the vector with a uh, random number generator, in our case, it ended up reversing the array, as well as vector that choose, which chooses a random number from the vector. Alright, now using everything we have learned, here's a basic demonstration of our guessing game. As you can see, we first import the rand crate. Then we use the random range function in the crate to generate a random number from 1 to 100. Did you guess that? Well, that's all the content I have for this lecture. Thank you for listening.